Yeah, hello, good morning or good afternoon, or for some of you, it might even be good night. I mean, depending from where in the world you're tuned into today's webinar. Really, thank you very much for joining, and yeah, welcome to the TDM webinar, Digital Manufacturing, the Importance of Tool Data. My entire webinar is supposed to be a brief introduction into tool management. What is it? Why are we doing this? And what are the benefits? And yeah, today it's about how a central tool database with optimal tool data is really a very important part of yeah, the, let's say, the added value or the bridge between planning and manufacturing systems. I will try to keep it short, a little bit entertaining, hopefully. I have a couple slides. At the end, I will show something live in the software. Basically, what it's supposed to be is a 10,000-foot overview of what state-of-the-art tool management is or what it can do. And I promise from time to time, I will lower my altitude and fly a little bit closer to the technical ground. Let's just say in the beginning, I can turn off, can I do this? I can turn off my camera real quick, so you see this is actually really live. I will turn it off later because I'm afraid the bandwidth could be a problem at one point. But yeah, I want to start now, and I hope you're all safe and healthy, and I assume at home right now, like me. So I hope you all sit comfortable. You have a beverage of your choice in front of you, maybe a water like me, or a coffee, or for some of you, it's already later. But now let's just dig into digital manufacturing, and I'm going to turn off the webcam right now to save some bandwidth. Yeah, maybe another thing, organizational, we're a bigger crowd, which is super. I mean, a lot of people join this webinar now. So what we did, you're all muted because it doesn't work if everybody talks. And it's a little bit tricky to answer questions during the webinar, but there will be time at the end where you can ask your questions in the chat window or in the question window, and we'll try to answer them. And it's planned to be like 25 minutes, 20, 25, 30 minutes, but I will hang around later on for 10 more minutes. If you have questions at the end, there is plenty time. Let me introduce myself real quick. Oops, let me introduce myself real quick, and I have to close this window. Let me introduce myself real quick. My name is Robert Auer. I'm Director of Global Business Development here at TDM Systems. I'm a software engineer by trade, but I did spend most of my entire professional career in the manufacturing industry. And I'm basically dedicated to tool management for over 10 years now. My background is quite international. I did work and live in the US for a while, over the years where I was responsible for certain European countries, China, India, Southeast Asia. But for the last few years, I'm focusing back in the United States. And what I just mentioned, that means a lot of traveling. But as I just mentioned, like most of you, I'm stranded at home right now. But it's not that bad because I look outside, I can see the sun is setting in the sky, there's a lake, so it could be much worse. So without further ado, live from my home office at beautiful Lake Constance, let's dig into digital manufacturing and talk about the importance and the benefits of tool management. We already did a couple of webinars, and usually at the end there were some questions about TDM. Who are we? Where are we located? What do we do? So now I'm going to put this here in the front and give you really just a brief overview. Who is TDM? TDM Systems is a leading software provider for managing tool data in the manufacturing industry. We're headquartered in Tübingen, Germany. Tübingen is a little bit south of Stuttgart, and it's a little bit north of my home office. We have a subsidiary in Schaumburg, close to Chicago in the US. And of course, we have quite a few sales and service locations around the globe. We have more than 25 years experience. We did Industry 4.0 smart manufacturing when the name was not even out there yet. A little bit more than 100 employees, almost 1,000 customers use our software, which turns into 1,000 users use TDM software every day. We are TDM, we are a member of the Sandvik Group, which is nice. We have a strong company in the back, and it gives us access to know-how of internationally leading tool manufacturers, as you can see. However, at this point, it's really important to point out that TDM is an agnostic, I think that's the modern word, an open software. Of course, we do not only manage Sandvik tools, we manage tools, period. We even create tool catalogs for Sandvik's competitors in the market. So yeah, but you might say we're like the Switzerland of tool management, completely neutral. And this independence, this openness is really key for digital manufacturing. And in this spirit, I also see that today's webinar, of course, I use TDM screens and you see the logo everywhere, but it is supposed to be about tool management in general, what state-of-the-art tool management is and what tool management can do for you. And yeah, if we talk about tool management, if I have presentations with customers, we usually ask, do you manage your tools? And usually the answer is yes, sure. But then if you dig a little bit deeper and ask, how do you manage your tools? The answer is usually can vary from, we have files, we have printouts, we have a couple drawings in a central file location, or I guess the general answer is we use Excel. That's kind of our biggest competitor, so to say. But this is, of course, if we talk about Industry 4.0, smart manufacturing, no longer state-of-the-art tool management. And I hope at the end of this 20-25 minutes, you will see why Excel has to fall short. Another answer is, yeah, we have the tool management part of our CAM system, or we have a nice machine control software which came with the machine, Maze Cyber Tool, whatever, DMG Celos, or we have a vending system that also has like a little tool management software. These are all nice tool management solutions. They're not bad. I mean, don't get me wrong, but they are island solutions. They only solve one isolated issue. And today I want to really look at the big picture. A software solution which supports all sectors of the manufacturing process. A software which manages not just tools, but really the components, the items, accessories, manages tool assemblies, and then of course manages the tool lists, the main documents for your manufacturing operation. So basically, we talk about a tool management system which supports the move from a more traditional static island solution to a more dynamic manufacturing process. So another word which you might hear very, very often, the digital twin. Yes, this is tool management, managing the digital twin along the entire digital manufacturing process. Because I mean, you know all what the physical tool is, but we manage the digital twin of it. And I will talk about this in a second later. But the entire idea of tool management is to make sure you have the right tool at the right time, right place, right quality. And we do this with a digital manufacturing process. And of course, we're not just talking about one system in that process, but let me click forward here a little bit. A typical manufacturing process, there are plenty of players in the field, and a system has to communicate with all of them, has to provide data to all those systems. And now my last slide in the introduction, and then we can really start with the webinar. I like it because it kind of visualizes what the tool management system does. You have a central database which supplies data information to the different areas in the manufacturing circle, in the manufacturing flow. And of course, you don't have to do the entire end-to-end process with the tool management system. Usually you start small. You start with a solution which covers your CAM area or your logistics needs, or a software which combines the vending systems with the presetter or the machine. So you can start small, but the goal is really to have one central place of truth where you have the tool data for your manufacturing process stored. So this was my intro, and now we're digging into the actual webinar. And I mean, you could already hear or see, or you probably felt it. It's a wide topic. I mean, we're talking about different systems, different areas. So there is a lot of ground to cover. So what we did, we divided it in 4 webinars, and they all, no worries, they all work on their own, but we focus on different areas. So today we talk about data, the importance of tool data, how harmonized data along the entire process is beneficial, and I will really show the entire flow of tool data from planning to programming, and then on the shop floor. We will have another one where we focus a little bit more on CAD/CAM or simulation, also show how to create the digital twin and things like that. Then another one about inventory and logistics, which is kind of the transition from CAM to the shop floor. We're talking about the integration of presetters, of vending systems. And then the last one is kind of the big thing when we talk about a shop floor automation, how to automate the workflow on the shop floor, use RFID systems, monitor tool life, and things like that. So this is kind of the big picture, and today's picture is the importance of tool data. Let's start with that. Let's see how a tool management system manages the tool data along the entire process with different interfaces to different systems. And let's have a look at the data flow between those systems. And I want to call up, come back to this picture I showed earlier. This is a process. This is a process which this is the manufacturing process which similarly probably is also in place on your shop floor. You have different areas. You have your CAD product lifecycle management area. You have ERP systems, CAM programmers. You do simulation. Maybe you have vending systems, pre-sellers, machines, and you have different vendors, different brands. And the goal of a tool management system is to be the central database and provide that data along this entire process. And of course, we have to have interfaces to different systems. And now back to this digital twin thing. What is the digital twin? It is kind of a complicated question, because if you look at the systems down there, every system has a different, different view on how the digital twin should look like. Just let me give you one quick example. If we talk about ERP systems, an ERP system is interested in a component, an item, and it needs an article number, price, a vendor. But then if you look at CAM programming simulation, it's a different story. You need the tool assembly, and you need different models, like a 2D model, a 3D model. You need parameters in order to do your programming. If you go further down this value stream, if you have a vending system, you want to have the tool assembly, but broken down in the bill of materials. So you have the components you need in order to assemble a tool, and you need a stock location, a quantity, things like that. And a little bit further down the road, you have the presetter. The presetter needs an assembly drawing, a tool length, a diameter, tolerances, things like that. And then last but not least, the machine, for example, tool offsets or tool life, things like that. So the point of this slide is really to give you a feeling that data, first of all, data is king. Data is the most important part of this entire process. And the way systems look at that data, let's just say the glasses they have on, can be different depending on the system, which is along this entire process. Of course, this is not a complete picture. I just wanted to give you a little feeling how this process looks like. And now let's have a look at the process. And I want to do this based on almost like a customer journey. And I actually chose that one because I really like this quote. We now spend more time preparing revenue-producing jobs and less time searching for information. Tool management increased our bandwidth. I mean, that's kind of the point. Not taking time searching for information. And if you would add this, not just searching for information, but also searching for components, searching for tools, and so on and so forth, we're getting somewhere, because search time, waiting time is a huge waste in manufacturing. This is kind of almost like the biggest factor where you can reduce your setup times and kind of increase your productivity of your machines. And it gets even better if we add kind of the transparency factor, or the factor that we can collaborate between different systems, because you can proactively create savings in the programming area, in the product development phase. You can influence the cost you have later in your manufacturing. So the two factors: reduce waste and better planning, better preparation. These are the two factors which are very, very important with tool management. So now really let's have an in-depth look into the process step by step. First of all, what is in the database? It's components. Out of 3 levels, you have the components with data, and then you can use the components to create, and let me do this here real quick, use a laser pointer. You have the component, and out of the components, you create tool assemblies. Here we go. You create tool assemblies. With the tool assemblies, you can do your programming, your simulation, and then the output of a CAM system will be a bill of material, a tool list with all the information you need for your manufacturing job. And this information kind of flows through the entire process. Let's start with step 1, kind of in the planning area, where you create your tool library with the items, the assemblies. And you add more information like documentation, fixtures, gauges, and things like that. This is This is the starting point of a tool management system, and this could be worth an entire presentation webinar on its own. I just want to give you an idea of what is possible to manage in an area. As for example, you manage your items, your assemblies, and your jobs, of course, but also documents you need on the shop floor. You can manage fixtures, gauges. Everything is part of this tool management database. And the idea is, of course, to centralize the data, to have transparency and know-how in one place, which is what I would call protected company know-how. It's independent from the people. It's part of the company know-how, and everybody who has the user rights has access to it. And of course, it increases the quality, not just of the process, but later on also the quality of the tools you bring to the machine. Transparency is important, and in the end of the day, it's an optimized process which gives you huge time savings. And I really like that picture, just the transparency itself. I mean, if you don't know what you have, what you see, you have a bunch of cutting tools, you don't even know what's in there. But if you can reduce that number of components and you organize them, all of a sudden you know what's going on. By standardization, the benefits are just huge. By centralized know-how, improved quality and time. And then, of course, more in the programming area as an NC programmer or for simulation, same idea. You have access to a central tool library, to a tool database. You know what's available. You have access to know-how. You know speeds and feeds. You know historical speeds and feeds. And of course, you have the digital twin for your programming. This obviously helps you to reduce scrap because you create your tool assembly in your CAM system. This is your theoretical tool, but then you transfer that information to the shop floor and you make sure the tool is assembled correctly, the tool is preset, and the offset data is transferred to the machine. And of course, the results minimization of errors. The process becomes much more reliable, and obviously the time savings. And as an additional benefit, you have the entire shop floor documentation by a push of a button out of the CAM system. And just here to give you one example, within TDM we have a data compliance check. So we make sure in the software that the data you set up in the system is valid, it's good to be used in different systems. I just put an example here, a boring bar, and TDM system, that's a screenshot out of the software, checks is the data in the system good enough for logistics, which is, I don't know, you need a stock location and things like that. Yes, it is. Is it good enough for different CAM systems? So you set it up once and it can be used in different CAM and simulation systems. And by checking that, again, we're back to process reliability, quality, making sure you get the right tool at the right place at the right time in the right quality. And then, of course, one central database, multiple CAM systems, multiple CAM programmers. It helps you to have a collaborative approach to your manufacturing or to your planning. So if you look more at like from a process level, now we're back to this process view here. As a programmer, or as a planner, I have access to a tool library with the components, with assemblies. I have access to documents. I have access to an NC program management. I have access to fixtures, to gauges. So basically, I have a huge knowledge base to start my programming with. I have tools to create tool data, graphic generators. This is something we're going to talk in the next webinar about. And then, of course, I can use all that data in order to do my CAM programming, to do my simulation, and so on and so forth. So just to give you one example how this transparency helps, we have a customer example where they saved almost $2 million in 12 months just by reducing the variety of tools in their shop. They reduced it from around about 6,000 tool assemblies to 3,000. So they cut it by half. It's just by having transparency, knowing what we do. As basically, let me switch back, which I usually don't do in webinars. You see this picture down there. Standardize, have transparency. You can reduce the amount of used tool assemblies. So. And the next step then is, of course, the shop floor. You do your CAM programming. The output is the tool list, the job sheet. And now we move on the shop floor where we have an ordering and an inventory integration. So the system automatically reorders components if necessary. If your drop is below a certain stock level, of course we can integrate inventory systems like a shuttle, a handle shuttle, or a tool cabinet. So in the end of the day, the idea is to organize your shop floor and also to guide your people to first of all have the right component, have enough components to assemble a tool in the first place, and then of course to assemble it with the right components. And then of course an integration into presetting systems, so to send the offset data to the presetter, preset the tool, get the offsets back, and then send the offsets back to the send the offsets to the machine. So again, another customer example, the typical questions, is the tool available? Where is it stored? Did I correctly select the items? Is it correctly assembled? Blah, all that stuff. The result was the customer saved 350 hours per year in setup time, and the scrap rate was reduced by almost 50%. Now, I do not know what the scrap rate was to begin with, but it was definitely reduced tremendously. This part will be covered a little bit more in detail in the two webinars, Tool Inventory and Logistics, and Manage Your Tools through the shop floor. Before I really quickly show you something in the live software, a little recap, why are we doing this? Of course, reduction of tool costs by 20% by having the transparency, the optimized grip inventory, and reducing the tool variety. That's the example with reducing tool assemblies, 6,000 down to 3,000, which means a lot of money within 1 year. Reduction of tool costs. The second benefit, the reduction of machine downtimes. I mean, in the end of the day, that's the end goal anyway. Your machines have to produce parts, basically reduce the machine downtimes. Typical example, 30% just by having the right tool, right time, right location, and then of course having the right tool data for machining. And the example was around about 350 hours per year saved in setup time, and reducing the scrap rate by 45%. And then last but not least, the efficient workshop process. Just by increasing your tool usage by 50% and have more transparency, you can optimize your planning, you have an efficient shop floor process, and you can increase your tool usage by having transparency, have the tools, the locations of the tools, and the stock levels and everything. So, and now I really want to show you real quick a couple seconds, a couple minutes, how the software actually looks like, so you get a feeling how tool management software these days can look like. And let me switch here real quick to our software, the TDM global line, and you should see the screen now. Yes, perfect. That's the home screen. You're a user, you enter your credentials, and this is your customizable screen. And you can already see it's always the same thing. We talk about items, we talk about assemblies, we talk about tool lists, we manage stocks, and that's about it. So let's have a quick look how a typical tool management screen looks like. You have your components, you have the 2D graphics, the 3D graphics, the parameters, stock locations, and of course the system makes it really easy to search for tools. I can enter a text here in like a Google-like search. Of course, I can select by tool type, by tool class. I can select by vendor, or let's do the technology, for example. I want to have a tool which fits my whatever cutting operation I want to do. You can see it's a tool. I know if it's available, is it somewhere in the stock? I know the speeds and feeds, I know the supplier, all that information by the click of the button. And as we have a database, a central database, it's super easy to check, is this component used in a tool assembly? And you can see, yes, this component is actually used in the assembly. So then let's just go through the assembly and see how the assembly is actually managed in the tool management software. Let's click on it, and this is the typical screen for a tool assembly. And you can see this is the tool assembly. I have, again, all the parameters. I have speeds and feeds. I have a bill of material. So if I want to create the tool, I want to assemble a tool, I have the bill of material, I know where the stuff is. And of course, I have the right parameters for all the CAM systems I'm using. And this is really important. We talk about digital twin. Different CAM systems have different need for data. That's just one example. Esprit needs that face mill as a face mill with those parameters and with those solids. So they need one solid of the entire tool, and they need two DXFs. A different system, let's use Vericut, for example, for a simulation, the parameters look a little bit different. And the 3D graphic, of course, it's a simulation system. You will see it's a nice 3D step file, and we have a DXF file of the entire tool plus cutting part, non-cutting part separated. So my point is, in TDM, we make sure you set up the data once, and then it's ready for being used in different systems. So, and then the last level is the tool list. You do your CAM programming, and after you're done with your programming, you save the tool list back in TDM, and let's just select one here. You have your tool list, you have your fixtures, your gauges, you have your documents, all you need, and of course you have your job sheet with all the tools needed for that job, and you can get them out of the vending system, assemble them, put them on a presetter, and this is how the entire shop floor process starts. Of course, there are a couple other features, like you can visualize what's going on. You have a dashboard, what jobs are on the shop floor, what tools do I use the most, how much money is currently in my vending systems, and things like that. That just comes with the central database. But with that, I actually want to stop the live presentation and go back to the presentation. And if you look at the time, you can see that I am actually done with the first part. And again, this was a quick overview how tool data is managed in a tool management system and how tool data flows through the entire shop floor process, from planning to programming, then down to the shop floor, vending systems, presetters, and then to the machine. The other three webinars will cover individual areas a little bit more in detail. And also, if you want to have a little bit more information, there's always a TDM YouTube channel. It's quite nice. There are a couple of things which are explained in detail in videos. I kind of like this middle one. It's called the Simple Show. It shows really how TDM optimizes the shop floor process. And then, of course, feel free to contact us. Go on our webpage and ask for a live demo, which is then, of course, completely suits your individual needs. And now, yeah, 30 minutes as promised. There is time for questions. Also, feel free to ask the questions right now. And again, I will hang around a little bit longer. And I will actually check here the question and chat window. And I have one question. Can send I have to read it first. Yeah. Okay, as the question is, can TDM send tool info such as the helix angle, rake angle, recommended chip thickness sent to simulation for feed rate optimization? And 50% of your question is part of the standard. However, you did see the digital twin I showed earlier, the tool assembly. This does not have all the features in there which you just asked for, but this can be sent to a simulation software, to a standard simulation software. Let me double check. Helix is in there, rake angle should be in there, chip thickness. This is something I would have to check in detail. And then the second question is, which simulation system? Of course, it's important you need a simulation system which can actually handle those parameters. I don't know if this actually answered your question. As a long story short, of course, we hand over the digital twin with all the parameters we have and all the parameters the simulation system can handle over to the simulation system. As a good example is, I think I showed it before, is Vericut. Everything is handed over. There is a toolpath optimization the NC code is optimized, and everything is a seamless process. And I think there's another one. Okay, instruction. Let me do this. Yeah, also the question is, does the software handle floor documentation? And there are very specific shop floor documentations, standard procedures, JAS, PFMEA instructions. What the system does, we manage documents. So in the end of the day, it doesn't matter what it is. So we manage documents. You have to have a viewer for those documents in order to view them. That's for documents. We have we manage certain shop floor documentation in a different way, and it's not really documents, but we manage NC programs, for example. This is not part of the document management system. NC programs is a different module. So NC programs, we manage certain things a little bit differently than standard documents. But for standard documents, we have a management system where you manage the version, who changed it, when was it changed. You can block it and things like that. And in the end of the day, the only thing you need is the software to view the document. So of course, PDF, a Word document, not a problem. But for example, if you have a more complex CAD drawing, you need the CAD viewer installed on that PC as well. Yeah, I think that what I was just mentioning, the documents, which were just examples. As a long story short, yes, document management, any document. Can be managed in TDM, first of all, as documents, and then they can, of course, attach to a component, attached to a tool assembly, or they can be attached to a job, to a tool list. There is the software compatible with Mastercam? It's kind of it's actually, let me do one thing real quick. That's kind of a really, it's a good question. It's an important thing to understand. TDM itself, in the background, it's a tool database. So we manage the tools. So here we go. And we have the components, the assemblies in our database. And we provide this data to different systems. And basically, we have the neutral database, and we map the data for the different systems. So we map the data for Mastercam, Esprit, SolidCam, Siemens NX, CATIA, Vericut. So we map it for different systems. So you set it up once, and we automatically make sure you can use it in the different cam systems, such as Mastercam. Okay, yeah, another question. All tools, gauges, dies, rolls in one location? Yes, as of course. If I understood the question right, is everything stored in one location? Yes, it's a central database, and everything is stored in this central database. Tools, gauges, fixtures, documents, NC programs, all in one location. Maybe also an interesting aspect, GlobalLine is built for, let's say, global access. It's not a cloud software, it's an on-premise software, but it's built, if you have a company network over multiple locations, you have one central database and different locations connect to this one server. And you can, of course, assign tools, gauges, fixtures, documents to locations. So you could tell the system, please, this tool can only be used in our location in India, in Pune, for example, and the other tool can be used in Tübingen and in London, and the other tool can only be used in whatever, Detroit. Also, yes, central location. B, access from multiple sites are possible, and everything can be assigned to different sites. If this answer makes sense. Mastercam is the software compatible. And now I'm running setup parameters. What is that? And there's a question about setup parameters. Okay. Speeds and feeds. That's always a, yeah. As speeds and feeds, what are we talking about when we talk about speeds and feeds? First of all, we talk about there are different levels. First of all, we get the quote-unquote nominal speeds and feeds from the tool vendor. So we enter this in our system. This is the basis. And then, of course, first of all, on a component level. Then we build the assembly, and we're still talking about theoretical values. You enter them. Then you run your operation, and then you realize, oopsie, we can cut a couple more holes or less. Then you can enter it manually in the system. That's one option. So it's kind of a manual depository of speeds and feeds. Second option is, of course, if you have a live connection with the machine tool, you can also monitor tool life and define actions on tool life. So if tool life drops below a certain warning limit, you can request a new tool for the machine. So it's two different things. We manage the tool life as a theoretical value. You can add historical data manually, and we can manage live tool life. Live tool life. That's a silly word. Floor documentation. So, and now I think I'm through most of a couple more. Setup. Is there an interface you have to buy through the CAM software to link with TDM, or is a TDM interface enough? I have to say this depends a little bit on the CAM software, but usually there is a quote unquote plugin in the CAM software, like we have one for Mastercam, one for Siemens, one for Esprit, which is provided by the CAM software. And then we have the interface on the TDM side, and that's enough. How the tools can be identified, DNC code. There's a question, how can tools be identified? I assume we're talking about different kinds of RFID, and this is something we're going to talk about in the third webinar. As there are different kinds. There are RFID chips like Bellof or IDEM. That you can use barcodes and things like that. There are different ways to do it. A good tool management software can handle all of them. It's more a question what you do. Then there was a question, can it be used for Vericut? Yes, of course it can be. Vericut is a very common system, especially as a second system. You have Vericut for me is a great example to show the benefits of tool management. You set up your tool once in TDM, and then you can use it in Mastercam, Esprit, but then also, of course, in simulation software. You don't have to set it up twice. And yeah, connect to my vending machines. AutoGrip. There's a question, does TDM connect to vending machines like AutoGrip? Yes, it does. There are interfaces to several vending systems, including AutoGrip. And also to shuttles like the Haenel shuttles or Modular, or there are a couple more. So will a recording be available? Thank you for that question. Yes, a recording will be available. Usually it takes a while to compile, and 24 hours, give us 24 hours, and it will be available on our web page. Is the interface, and I think, I mean, it's always also 40 minutes. I think I'm through with most of the questions. If Mark Aurelius is still here, maybe just an add-on to the speeds and feeds question. I think my answer was a little bit misleading. One is really just about the tool life monitoring, and you're talking about speeds and feeds. It is really about we manage them, and you have your original values you get from the vendor, and then of course you can add additional information based on your knowledge, on your historical value, and we can also add multiple speeds and feeds to for example, tool assembly. So if a tool performs differently on different machines, you can add this, and those speeds and feeds are also automatically transferred through the CAM interface to the CAM system. So you set it up in TDM, you call it up from a CAM system, and the right speeds and feeds are automatically transferred to the CAM system for programming. And I think I'm through with most of the questions. Yeah, thank you very much. And it's really important. If you have more questions, feel free to ask them. Send us a mail. contact us through the webpage, no problem. We're here for you. I'm more than happy to answer them in detail. And of course, if you want to have a more in-depth presentation, this was really an overview, a quick run through. No problem. We can do live presentations. Okay, right now it's remote presentations, but I personally really hope that I will be able to visit you in the near future again somewhere. That would be very, very nice. But in the meantime, I would say, yeah, thank you very much for joining. It was really a pleasure for me, and the time you spent is highly appreciated. Thank you all, and yeah, see you soon in a webinar or somewhere around the world. Thank you.